As I've done now with several other modules, I'd like to show you how to compute the practice problem that appeared at the end of the module using Excel as an advanced calculator. So in order to do that, I've pasted here all of the formulas that we'll need from our formula sheet in order to compute the ANOVA. Of course, there is one thing that's missing, and that's when we compute the sum of squares within, we have to be able to sum up the individual sum of squares for each treatment. And since we weren't given the original sum of squares for each treatment, we have to compute that ourselves for each of these conditions, for each of these sets of 5 scores. So I am going to need this additional formula here. That's the sum of squares for each of the individual conditions. You'll notice that at the denominator of this second part of the equation here, we've got a big N. And the reason why we have that is because when we were first learning how to compute the sum of squares, we were learning about it for populations. And so I had put this big N in your formula sheet. But of course, in this ANOVA situation, the big N represents for all 15 of these scores. But we're not actually computing the sum of squares for the whole set. We're computing the sum of squares for each of these columns, for each of these individual sets of 5. And so we're going to use this little n, whatever that ends up being, because we want to use the number of scores in the set that we're computing the sum of squares for. So as a reminder, we're just seeing whether the richest people are happier than the poorest people and the middle people, whether there's differences across these groups in their happiness ratings. So each of these are the scores of a person who is either in the richest group or in the middle group or in the poorest group. So we've got a total of, as you can see here, 15 people, and I'm going to put that here as the big N, 15 people here in our group. We've got a grand total of scores that is equal to the sum of all of the values in this table. And the sum of all the x's squared is, if we were to square each of these scores and sum them up, then that would be this here. In order to do that, I'm going to open up a new sheet here so I don't confuse us. And I'm going to make this equal to this value times itself, and push enter. And then I'm just going to repeat this for each of the 3 columns and carry it down for each of the 5 scores. And this right here will give us a square of each one of those values. So what all I've done is just squared each of these values. 4 squared is 16, 5 squared is 25, 16, 25, and so on, right? So I've just got a square of each of those values, and I'm just going to sum them up. So I'm just going to take equals the sum of all these values on my other sheet over here. That's my sum of x squared. In order to get that n right here, I can just add them up. There's just count them up. There's 5. I can just type 5, or I could write equals the count of how many there are in that column, and it would also give me the same thing. So we just get 5 there. And then the total of the column right there is what t represents. So I'm going to do the sum of those. And the sum of squares, as I just mentioned a second ago, is equal to the sum of the x squareds in this column minus the sum of x in that column squared over n. So here I'm just going to put a couple of reminders of what's going on here. I'm going to figure out what is the sum of x squared in this cell for this column, in this cell for this column. So first I'm going to take the sum of all the x squareds, which remember we did over here. Those are all the x squareds. Added up is in this 3rd row. I'm just going to take these 3 and paste them in over on this side as values. So they're there. And then here I've got the sum of x squared. Of course, the sum of x is t. So I'm just going to square my t. T times itself. And then divide that by n, which is 5. Carry that across, and there I've got all of my sum of x squareds over n, which is the second part of the problem. So now I just have to take the first thing we computed right here and subtract the second thing we computed right here.
So that equals 91 minus 88.2, and I just carry this across so that it's doing it for each of those columns. And now I have the sum of squares for each of those conditions. After I've computed that, I should have everything else I need in order to compute my ANOVA summary table down here. So I'm going to go back to my original ANOVA formulas. I'm just going to get this one out of the way. We're done with that. So we've got our sum of squares total being the sum of x squared for the whole thing minus g squared over n. So we've got the sum of x squared here is 187 minus g squared over n. And since I need this g squared over n for both of these kinds of sum of squares, I'm just going to put that here. I'm just going to put g squared over n and figure out what that is. And that should equal g times itself divided by n. There we go, 160. So now I can just come down here to the sum of squares total and write that this equals the sum of x squared minus this g squared over n. For my sum of squares between, I can take the sum of all my t squareds over n, which I should probably put over here, t squared over n. And in order to do that, we just make this t times itself divided by n. And you'll notice that that's the same as what we already computed before for the sum of x squared over n, because t is the sum of x. So if I do this across, that's actually the exact same thing what we already did. So we already had t squared over n. But if we take each of those t squareds over n and we sum them all up, then we've got there the first component, 181, of this equation. And we take here for sum of squares between, we do this equals the sum of all those t squareds over n right there, minus the g squareds over n, which are right here. And that's our sum of squares between. Our sum of squares within is to take the sum of squares for each treatment and add them up. I can do equals the sum of each of those things. And if we were to add 20.9 plus 6, it equals 26.9. And so you can see that we're on track. We can then proceed to our degrees of freedom total, which is big N, 15 minus 1. Down here we can just write 14 if we want. Our degrees of freedom between is k, the number of conditions, which is 3 minus 1, or 2. And then finally, for degrees of freedom within, we take the sum of our degrees of freedom for each group, n minus 1 for each group. So 4 and 4 and 4 is 12. Finally, for our mean squares, we are computing the variance, which is the sum of squares divided by the degrees of freedom. And we do the same thing for the second row there. And our F ratio is the mean squares between over the mean squares within. So we just do that divided by that, and we get our F as 20.93.